Aspects give us a way to modify or perform checks on resources before they are synthesized and finished off into a CloudFormation template. And you might be wondering for some example use cases of this, and if you've looked at the CDK NAG lesson, then you'll know one really great use case, which is checking resources against common compliance standards or common security best practices. But we can make our own aspects if we like, and let's see how we can do that. In this case, we're going to make an aspect that will automatically set up the tracing configuration on a Lambda function. So we've got a few Lambda functions in this stack. We've got one for a bit of testing just to get some metrics out of it, and we've got one of them which is made as part of a custom resource. If I have a look at this tagged alarm construct, you can see we are creating another Lambda function here to actually do some tagging. So what if we want to put some tracing settings on every Lambda function in our application or in our stacks, even if we haven't made them, even if they're part of another construct made by a third party or another team in our organization. So we can go up to the top level here where we've got our application, or we can do it by stack as well, but we'll do it on the app. And we're going to say aspects.of, then our app.add, and then this will let us add our own, but we have to make an IAspect. So let's do that. Let's make, let's call this AutoTracingAspect, and it's going to implement IAspect. Okay, and then we can add a new AutoTracingAspect into our app, and then we need to make sure that we implement all the methods that are required for our aspect, which in this case is a visit method. And the visit method will go node by node all the way through our constructs and any other constructs we've got in the app, and we'll let you do something with them, either modify them or inspecting them and adding some kind of annotation to say there's a problem. So let's put a console log in here, and I'm going to say hello from then the node, and let's see how we can get a debugger going which will help us in our development of this aspect. So there are two areas you can add debuggers to in CDK. One is the CDK CLI, and one, which is the more common one, is when you're actually running your code that's generating the application and stacks and resources and everything else. And the app debug key here isn't read or used by CDK. It's just a way of me storing the debug configuration in my cdk.json so I can use it. So I'm going to rename app to app normal and app debug to app. And you can see we're running node with inspect break to launch the ability to connect to debugger and to pause the program and wait. Then TS node and then our application. So let's do a synth. And you can see that it is asking us to connect to debugger. So let's do that. And if we stick a breakpoint in there, whoops, I was too slow. So let me run that again. And let's start the debugger. Lovely. So we've hit our breakpoint, and now we can inspect the node and see what it is, and we can go through each node and try and decide, which ones we're interested in. So the first node here is an app, that's the class. The next one is a very alarming stack, which as the name would imply is a stack. And then we get into a Node.js function, and a role, an imported role, a CFN role, policy, CFN policy conditional, asset, asset staging, import, CFN function. So you're seeing a mix here of classes that are CDK constructs or abstractions and classes which are level 1 constructs. They're the raw CloudFormation resources. So we have to decide at what level we're going to do this manipulation of our tracing setup. So we'll do it at the CloudFormation resource level or the CFN function level. So let's add a little check here. We're going to say if node is instance of CFN function, and then we will do exactly what we did before. And I'm just going to stop the debugger here. I'm going to restart our synth, and then I'm going to hit the debugger again. And then we can see we've just broken now when we've got a CloudFormation function, and we can skip through these, and then we're done. So we've verified that our check here is working as we expect. And then when we're inside this if statement, TypeScript will know that it is a CFN function because we've just verified that. So we can look at the properties on our CFN function. So we can do things like call a method on it. We could set some tags if we wanted to, or view the tags. We could change the code property. There's a ton of things we can do here. But the one we're interested in is tracing config. So we're going to set that. And let's go and have a look at tracing config and see its shape. And there's a mode, and the mode I think can be enabled or disabled with a capital letter. Tell you what, let's double check that in the docs while we're here. Why not? Oh, active or pass through, sorry. So let's change it over to active. Okay, we are going to uncheck our breakpoint for now. I think we're fine with that. And we'll just run a regular old synth into a file. Oops, I've set the debugging up in app.json. Have a nice. Let me pop that back to the normal setup, normal configuration. Okay. And in our template.json, template.yml, we can now see what's going on. And you can see I've got my console logs in here, which isn't very helpful. So I'll tell you what, let's take those out because they're messing up the synth output. All right. So we've got a role, we've got a policy, and we've got a Lambda function. And we can see under the properties that we have tracing config mode active. Let's collapse that Lambda as a CloudWatch alarm, custom resource, role, policy, and another Lambda. And again, in that Lambda, we have a tracing config. So that's one thing we can do. We can manipulate the resources if we like. We could also do some checking of them and make sure they are in a certain configuration or a certain approach. So let's do that. So one challenge we have if we're looking at this node.tracingConfig property is that it might be a value we can't see yet. It might be a resolvable. And if you imagine if you're referencing a resource from another resource, so one property is the Lambda function ARN, you're referencing a Lambda function for that. It might not know about it up front, might not have turned that into the reference yet. So we won't necessarily get a concrete value you can actually test and look at, but there is a way that we can check if this is a resolvable. If we call tokenization, dot is resolvable, and then we give it the property we're interested in that could be a resolvable, and we can say if that isn't the case, then maybe we can do some inspection of it. And then at the next level, mode is just a string or undefined. That's not a resolvable, or not something that can be a resolvable. So we can say if node.tracingconfig or node.tracingconfig.mode does not equal active, then we will inform the user that something might be wrong. So let's add an annotation to our node, and let's have a warning. We can put, you should turn on active tracing. Whoops. Messed up the if there. All right, let's give that another synth and let's see what happens. So we get two warnings here, and it says you should turn on active tracing. Let's go over to that Lambda function that it's complaining about, and let's set that. Let's go tracing.active, and let's run it again. And there we go. Now we're down to one warning. So we looked at making an aspect by creating a class that implements IAspect. We got a visit method, and the visit method is called for each node in the thing that we've attached the aspect to. So we attached the aspect to the application, so it ran for each node in the app. And it let us do things like modify properties or inspect properties and report back if we thought something was wrong. If you're trying to do this for compliance reasons, check out CDK Nag, because that's got a lot of built-in stuff that will be really, really helpful. But you may find you still have to write your own aspect.